Okay, welcome everybody. We're about to get started here. This is one of three workshops that we have in the program today. Just so you know, the workshops are basically double slots. So this is basically in length equivalent to 2 regular talks. Just keep that in mind, just in case you did want to see the second one of the parallel talks that we also have. I'm of course very happy if you stick around until the end, but if there's something super interesting that you absolutely don't want to miss, I'm certainly not going to keep you from that. So I'm going to give the last few people who just arrived a chance to snap this one, and then we'll get started. What we're going to be talking about today is building and operating learning management systems on Openstack, or to teach Openstack, or both. And I'm going to explain something about the architecture, and I'm going to show you that live as well. And if you want to, you also have the chance to interact with one of these systems yourselves. So what was the motivation for this whole thing? What's the general motivation for what I'm talking about here today? When we look at specific challenges that people have, or organizations, companies, enterprises have to adopting distributed technology. So like pretty much any kind of technology that has evolved sort of in the last, I don't know, maybe 5 to 10 years. Then we'll see that, or you would think that there are 3 major challenges that people are commonly facing. So one of the challenges that people or enterprises or organizations would typically face, you would think, is a challenge of cost, right? So the necessity to keep costs down, expenses down, keep margins high, and so forth. People might also be running into issues of scalability, right? So who's run into scalability issues before here with any kind of distributed technology, right? That's relatively common, which is the ability to quickly adapt to massive growth in demand or in your customer base for your products and services. And another typical challenge that you might think about is speed, which is, of course, the ability to ramp up and to innovate and to go to market very quickly. And yet, if you ask the question of what of these are the biggest challenges, or what is the biggest challenge to adoption of modern distributed data center technology, you will quickly find out that in reality it is none of these. But the actual challenge that you're mostly dealing with is a question of skill, right? Because there's all this new technology that is out that's very interesting, that everyone wants to use. OpenStack is one example. Docker, Kubernetes, Mesosphere, software-defined networking, NFV, blah, 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 you name it. There's tons and tons of those. But the problem is really not so much sort of adopting the technology, but finding and working with people who can actually run and operate it, right? And the people that already know this kind of stuff, they're already, they're usually very well employed. They're quite expensive, and poaching is generally not a very sustainable strategy for a community as a whole, right? So that raises the question of, if we need people that have all these skills, that understand technologies like OpenStack, like Kubernetes, like Docker, and so forth, why don't we train them in a manner that is cost-effective and scalable and fast, in a manner that also works for distributed teams, which not necessarily work out of the same office, or even in the same country, or in the same time zone, and so forth? I'm assuming that at least some of you will be working for the research and development facilities of companies that are based in the United States, or based in Asia, or based in Europe, and I think you're very well acquainted to the challenges that come with having a distributed team, or sort of the person that your manager reports to sitting in a different country and in 8 time zones away, and so forth. So we absolutely need this sort of thing. We absolutely need training facilities. We need the ability to sort of build up knowledge quickly and scalably and fast in a manner that works for distributed teams. And it turns out that when you look at the way training is commonly done, ramping up knowledge on these technologies is commonly done, you find that it's actually a terrible match. It doesn't really fit the purpose at all. because one of the options that we have, obviously, is sort of instructor-driven, face-to-face training. That has all sorts of issues. You have to wait for someone to actually become available, to fly in on site. You have to actually get your team together in the same place. For the duration of them training, you're sort of pulling them out of whatever other project they're working on. That's terrible. Who in here has done some sort of self-paced online training before, anywhere, like about any kind of technology? Have you undergone, some sort of online training? Well, if you have, tell me if it looked roughly like this, right? You basically listened to, either a talking head or maybe someone doing a voiceover over a screencast, and overall it was basically terribly boring. Right? It wasn't very engaging at all. Okay, I see a lot of nodding heads, right? So this is clearly something. It doesn't at all sort of tend to the way we as humans learn and acquire knowledge, right? So this is something that you definitely don't want to do, and yet most self-paced online training works exactly like this. You've got you're listening to a talking head. You have very little interaction. Sometimes you don't even see a face. There are some vendors out there, the only thing that they will do is they will provide you with a screencast and a voiceover, and that's it. And the rest of your knowledge acquisition is something that you're expected to do by self-study using documentation, right? Now, this is something that, to me, feels like the equivalent of this is approximately you've got an astronaut, right? You've got someone training for space flight, and the only thing that you make them do is you let them sit in the lecture theater and studying books and giving them a few tabletop exercises. And once you're done with that, you take them out of the lecture hall and you strap them to a rocket and you send them into low Earth orbit without them ever having set foot in a simulator, right? That's not a model that's going to work. In fact, it's a model that's rather quite broken. So we need something better. We need something different, and we need something that suits that those requirements better. So we need learning environments that actually help you learn what you want to learn and what you need to learn. We need learning environments that allow you to sort of immerse yourself in the technology that you're dealing with. And of course, all of this needs to include the ability to interact with your peers and exchange knowledge and so on. And we believe it's also imperative that a learning platform like this is based on open source technology, because that means that you can profit from the innovation that is rampant in these open source and openly innovating communities. Now, the platform that we selected for that purpose is a platform named OpenEdX. Who has heard about OpenEdX before? One person, two people, okay, three people. So OpenEdX is a platform, an open source learning management system platform. It originally came out of MIT. It was originally called MITx. Then the people down the street at Harvard University also sort of joined in the effort, and finally another large U.S. university across the continent, Stanford University, jumped in as well. And by now, OpenEdX runs edX.org, which is a large learning management platform that is operated by a number of United States universities or universities in North America. And it is also, OpenEdX is also becoming a platform of choice for professional training. The first major large commercial entity that became a member of the OpenEdX Foundation was, anyone venture a guess? Anyone want to guess? Exactly. Starts with an M and ends in Microsoft. So Microsoft was interestingly one of the first companies, non-universities, that actually jumped on this bandwagon. And OpenEdX is the stack is basically the software stack that runs edX.org, but is available to anyone else as well who wants to run it under the terms of the Affero GNU public license, the AGPL. As of last year, this is something that they announced at their annual conference, OpenEdXCon, which is just around the corner for this year. This year it's happening on the Stanford campus. Last year it was in Boston, Massachusetts. And last year they announced that for the first time there were now more people learning on OpenEdX platforms that were not edX.org than on edX.org itself. So that's a nice testament to sort of the growth of the community there. So that gives us a very nice learning management system, a nice learning management platform to build on. And then there's OpenStack. That's basically what we're all here for today. And we wanted to do two things. We wanted the ability for anyone who ran some kind of OpenStack environment, whether that's your private cloud or whether that's a tenant on a public cloud that you usually work with, to basically deploy these learning management systems there in a simple and easy and automated fashion, and also to fully integrate that with the learning management system for fully immersive lab environments. So basically combine these two, OpenStack and OpenEdX, and then provide with that a learning management platform that is completely universal and can basically be used for teaching any kind of distributed technology. So for example, if you wanted for your team to come up to speed on, say, Docker and Kubernetes and Mesos, you could provide them on demand with effectively any number of machines that they can then use to deploy a Kubernetes cluster on, right? Or maybe what you want to do is you are currently running on some sort of legacy SAN storage, and you now want to enable your people, your team, to learn Ceph. And you want to give in training every single one of your people who's ultimately charged with learning Ceph their own, say, 15-node Ceph cluster, as opposed to actually having to buy all of that hardware, just make it available to them on demand. Or you could do the same thing if you're, if you're in a big data space, you could do the same thing for, say, a Hadoop or a Spark cluster, or something like that. So with that, what you effectively get is a learning environment that is cost-effective, that's scalable, and that's fast, and that's all built on open source technology. And combine all of that in effectively one platform. So I can show you a little bit of what this looks like, and you're going to get a chance to look at that yourself in a little bit. So hang on a second. How do I do this? There you go. Okay, so this is one of our courses. It actually teaches people OpenStack. It's about learning OpenStack effectively from the ground up. As you can see there from the lesson plan, this is something that basically allows anyone to learn to build and deploy an OpenStack compute cloud from scratch. So it deliberately talks only about sort of the bare minimum of what you need in order to build an OpenStack compute environment. It talks about deploying Keystone, deploying Glance, Nova, Neutron, Cinder, and Horizon, and that's it. The important part is that as you go through this material, and I will show you in a little bit how you can access that yourselves, you get sort of your standard, a relatively standard deck of slides. I say relatively standard because we do apply, or we do adapt our slide decks specifically for the purpose of self-paced learning, which I'm sure you'll agree is it has a slightly different dynamic than when you're dealing with an actual instructor. There's actually more information that you need to put there in writing, basically stuff that for an instructor would normally be in their speaker notes and so on, and at the same time just provide some additional information there. But the important part here that's happening here is here in this case we are actually bringing up from scratch an environment that the learner can then use to deploy OpenStack on. So this is not something where we're actually providing them with an OpenStack environment already, but instead what we're doing is they're actually building this up from scratch as they go along. So let's see, apparently we're having a slightly flaky network here, so let me just reload that, and it should be right up because the stack has already come up. And what they get here, what people actually get here, is they're basically being dropped right into an environment that has been created for them, and what they can interact with is not just a single box or anything like that, but you actually get a full environment that consists of a total of 4 boxes here, right? And we call these boxes Alice. That's one. Then there's Bob. And then there's Charlie, and we've also got Daisy there, all right? And in the end, what this thing actually becomes is a full-blown OpenStack environment. So what I can do here is I can quickly check as to where am I really here. I can hasip.com. So that's my IP right here, the 64, whoops, and let's see. Oh, come on. So what was it? Up. Where are we at? 7781.664. 7781.664. All right, and here, this is basically where you end up at the end of the course. You effectively get a full-blown deployed OpenStack as you go along, right? And we can take a look here real quick. Here's our system information bits. So as you can see, we've got all these services deployed. We've got our Nova, we've got our Cinder services, we've got our Neutron network agents, and so on, right? So if you want to know how this works, if you actually want to take a look at this, then please do 2 things for me, which is you can go to academy.hastexo.com. I'm sorry. Go to store.hastexo.com first, right? Okay. You don't actually have to buy anything for the purpose of this talk here. Obviously, you can, and you can show this to your colleagues, but you certainly don't have to at this point. But what I want to point you to is there's this login or register button up at the top, and if you register there and contact me after, then I can totally show you. I can basically invite you to one of these courses, and I can show you how you walk through these initial steps here, right? So you just go to login or register up here, and then you can either log in or create your own email address and password, or you can also scroll down here and just log in with a Google identity, right? And then if you just approach me after during the lunch break, I'll be happy to pull you in there. So just, if I may, just a few words about sort of what this course does is you're effectively building an OpenStack environment from scratch. It happens to be based on Ubuntu, and you happen to be using Juju for doing that, but that's by no means a requirement. That is just sort of the way that we've built this. Now, let me give you a little more detail here about the architecture, about how this works. Because not only can you use this platform to actually learn OpenStack or learn Ceph on it, you can also run this platform, operate this platform in your own organization. Everything that I'm showing you here is open source, apart from the courseware content itself, but all of the platform content is obviously open source. So let me walk you through that. There we go. And let me go back to these slides here, and let me show you how that works and how that operates. So first of all, why did we do it this way? Why did we build this with OpenStack and OpenEdX? Well, very briefly, why would you want to do this with OpenEdX? OpenEdX is a learning management system platform that is very open. It has a large community. We like the technology that it's built on. OpenEdX is almost purely Python. It's a bunch of Django applications in Python, which is something that we like. And OpenEdX has this very nice extension format, or it has these nice extensibility features. OpenEdX calls these X blocks, and this allows you to effectively plug additional functionality into this, and we're using that for our lab environments. Why would you want to do this with OpenStack? Well, again, it's a very large and a very open community. We like the technology. Most of it, basically all of it, is Python, and it's easily extensible. You notice a pattern here, right? It's basically exactly the same motivation there. So how do we deploy OpenEdX on OpenStack? So who in here actually operates an OpenStack cloud environment in their organization in some shape or form? A handful. How many of you use an OpenStack environment regularly? Okay. So for those of you who use an OpenStack environment quite regularly, who of you are familiar with Heat, with OpenStack Heat? So briefly, for everyone else's benefit, Heat is an orchestration facility, an orchestration component in OpenStack. For those of you who are unfamiliar with OpenStack Heat, maybe you're familiar with Amazon CloudFormation in Amazon Web Services. AWS CloudFormation, just like OpenStack Heat, allows you to define effectively an arbitrarily complex environment in a single template and then manage that as one coherent stack. So that means you bring the stack up as one. You can subsequently, the stack has a life cycle. You can update it. You can make certain changes to it. You can freeze the whole stack, basically suspend it, and you can bring it back up and delete it as one thing. So the stack that we've defined here is one that consists of a cluster of backend nodes. This is something that OpenEdX uses for its own internal purposes. It has some persistent data that it puts in a MySQL relational database. It has other data that it puts into a content store that's in MongoDB. For both of those, you need some form of high availability. We simply do a MongoDB cluster here and a MySQL Galera. So that's basically the backend. And then you have a bunch of front-end application servers. These basically run relatively clever Django applications, and a bunch of them. They use RabbitMQ to communicate amongst each other. And importantly, whilst you always have 3 nodes in your backend, because that's something that is pretty much the only thing that makes sense, considering you're using MySQL Galera there. The number of application servers is entirely dependent on the load that you put on the system as a whole. So you might want to start out with just 2 or 3 application servers, and at certain peak times, you might want to scale out to 10 or 15 or something like that. This is something that OpenStack Heat allows us to do very, very simply and very easily. We do use a few features in Heat that you might consider advanced, such as, for example, resource groups. But by and large, it's a relatively simple setup. And then we use Neutron load balancing. The Neutron LBAS, a load balancer as a service facility in OpenStack Neutron in the networking component, for load balancing access to our front-end servers. And then you also you have to have a deploy node in there, because all of OpenEdX is orchestrated using Ansible. So you're doing basically all of your application deployment with Ansible. And so as a result, you need that as well. So this is basically the reference architecture that we embodied in a Heat template. For those of you familiar with Heat, this is basically the set of resources that we use in the Heat template. We define our own little private network. We plug that into a router that we create. We use Cloud Config, which is a means of using heat to actually to tweak the configuration of individual VMs. A really, really powerful utility. That was a subject of my talk that I did at Openstack Israel last year. So if you need to come up to speed with heat and Cloud Init and Cloud Config, there's a video for that up on YouTube. We then have our deploy node, our load balancer, our 3 backend nodes, and any number of application servers. You can run with as few as 1 application server. You might have 2, you might have 3, you might have 10 or 15. And we place all of that in a resource group, and then we simply define through a heat parameter how many of these do we want. So how many instances of that do we want? And that basically gives us our number of front-end servers. The heat template can be heavily parameterized, such as, for example, what is the secure shell key that you want to inject into these? What public network do you want to take your floating IP out of? Every cloud provider has their own sets of VM flavors that they define for Nova, so you need a facility to do that as well. You want to be able to provide the size, basically the amount of data, the amount of storage space that you want to make available to MySQL, Galera, and MongoDB. And of course, you also want to be able to define the number of application servers. And then you get an output out of that, or 2 outputs really. And those are 2 public IP addresses or 2 floating IP addresses, namely the floating IP for your deploy node, and the other one is the floating IP of the load balancer address in front of all of your front-end servers. So, and this was this part of the work that we did as far as the OpenStack OpenEdX integration is concerned, the ability to run an OpenEdX stack in a simple and easily reproducible manner on OpenStack, on an OpenStack cloud. That was one of the things that we wanted to achieve with the OpenEdX OpenStack combo, because edX themselves are very much focused on AWS. They run basically all of their services on AWS. I wouldn't say they don't care about OpenStack, but they certainly don't put any engineering resources into that. But this was basically the easier part. That was the lesser challenge to actually do. The important part was the ability to leverage OpenStack from within OpenEdX, because the same kind of orchestration capability is something that we can also use to do what I mentioned earlier, which is to give every learner a stack of arbitrary complexity that they can use to then deploy services on, or in short, to give every learner, to give every student a whole cluster to play with. Whether that is an OpenStack cluster, or whether that's a Ceph cluster, or a Docker Kubernetes cluster, or whichever. Now, for those of you who use public clouds and want to leverage public cloud facilities for training people, you're quickly going to realize that there is a cost consideration here. Because if you're giving, say, you've got a group of, 15 people that you want to bring up to speed on Ceph. And now for these 15 people, every one of them should now start to learn Ceph on a 10-node cluster of their own that they can play with. And you have a period of a month to train them, right? You have a period of a month for them to come up to speed. And they can learn at their own pace, but if you now have like 15 VMs, 10 VMs for 15 people, so that's 150 VMs, presumably relatively beefy VMs running for an entire month, that's likely going to break the bank. I mean, it's going to be a budget consideration. You don't really want that. Heat to the rescue. Heat helps us a great deal here, which is, as I mentioned, if we define a stack in Heat, we can easily suspend that stack and then come back to it when we need it next. So what our OpenEdX contribution was, our OpenEdX X block that we wrote, is something that can not only spin up such a stack, but also automatically suspends it when the learner is idle. So the moment they stop working on this stuff, it suspends, and the moment they come back to it, it comes back up. And so just to give you a reference point, what we're basing our calculations on is the amount of money that you're going to be spending on a public cloud provider for a person running a distributed cluster like that for a month is going to be approximately in the $20 to $30 ballpark, so per learner. So you can imagine that, you know, for something like a reasonably scaled out Ceph cluster that you're making available to every one of your attendees, you're going to be spending about 20 to 25 bucks on a public cloud per learner per month, which is very, very bearable compared to maybe, you know, 1,500 that you would otherwise be spending on a similar environment. So what we do with Heat is we provide a new stack for each student, and that stack suspends when it's not in use. And we do that through an edX XBlock. And that XBlock, of course, is itself open source. It's available on GitHub. It's under the AGPL. And you can use that in a very simple fashion. So this may look like a bit complicated XML. I can assure you, number one, it's not really that complicated. Number two, you can build all of that from an environment called OpenEdX Studio. So that's basically a content management system for your courses that you can use to deploy this. I just did a workshop specifically on OpenEdX. It was a 2-day workshop that I did in Switzerland just last week at Switch. Switch is is a service provider organization for Swiss universities. I had one of my attendees who, as they walked out, this was on Monday and Tuesday, I had one of my attendees, as they walked out of my workshop, they said, this is going to be very helpful because we have a meeting about these issues tomorrow. And the next day, and he had a demo scheduled at 2 p.m. the next day. And between 8:30 and 2 p.m., between 8:30 and lunchtime the next day, he basically built a course with this integrated and demoed that successfully. So it works, and it works in a reasonably user-friendly fashion. And then what we also do, just a detail, you know, we don't reuse SSH public keys. We only use an SSH public key that is auto-generated for that very stack and gets thrown away with the stack and so forth. And you're of course able to connect to this whole thing directly from your browser, as I just showed you, right? So generally speaking, this is our equation here. We like this, and we think it's a very, very powerful platform. So let me go back here now. And let's see. Sorry. Pull this back here. There we go. Okay, so let's see if there were people who registered there. Okay, so we have a handful of people there. Okay, so Liran Yugev, is that you? Okay, you registered, right? Okay, so let me see if I can pull you into the course here. And there were about 4 or 5 other people there as well, so I'll see what we can do there. Okay, and then also there's Tomer. Tomer at Gmail, who was that? Left already? Okay, I'm going to pull in another few people here. Okay. And you guys can check your email real quick. You should have gotten an invitation there. While you're setting yourselves up here, let me show you one other thing. So what you saw here in this environment, oh, by the way, here's I just hadn't touched this thing for it's basically if I close my browser window, my stack gets suspended for me within 2 minutes. If I stay logged in on my browser but I just don't touch anything, then it gets suspended after 10 minutes. And I get this pop-up here saying, hey, we think you're idle. If you want to come back to this, then you can resume your stack. And if I do that now, then we're also going to see that I'm being dropped right back into my session where we previously were. But that's not what I wanted to show you here. So this is the stuff that is on Hestexo Academy. That's our company, and these are the courses that are available there. However, something that we just announced today, the press release to that effect just went out a couple of minutes ago. So this is something where we've collaborated with the folks from Gigaspaces, some of whom are here. So you can now learn Cloudify this way. So if you want to get yourselves introduced to Cloudify, and rather than basically getting your own hardware for this and setting it up and installing it and blah 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 and then doing Cloudify on there, you can simply drop in here and you get an introduction to Tosca. You get an introduction to how Cloudify helps you implement Tosca and how you can run distributed applications directly from a Tosca blueprint, and you can do that right here. It uses just exactly the same technology that I just mentioned. It's themed slightly differently and whatnot, but it's the same stack. It's also OpenEdX and OpenStack, and we're very happy and proud of this collaboration that we just announced today. Let's see. Okay, so that's still resuming. Fine. For those of you who got an invite, well, you can't see anything on your dashboard yet, but you can go to Find Courses, right? And then you can enroll in this course that is called, actually, let me show you that. Let's do this. Here we go, courses. Okay, so there's one that's called Cloud Fundamentals for Openstack, June 2016. And that's the one where for you it should say enroll as opposed to enrollment is by invitation only, right? And you can drop in here, basically enroll in this course, and once you are enrolled, then you can also say view course, and you can go actually into the material, right? You know, by all means, feel free to fire away. What you're going to be doing is, if you basically get your OpenStack basics in terms or fundamentals in terms of slides for every one of the OpenStack services that we're covering: Nova, Neutron, Cinder, Horizon, Glance, Keystone, and you're building an OpenStack environment as you go along. And if you run through all the labs, you basically get sort of step-by-step instructions in all the labs. Once you've run through them, you actually have a working Ubuntu OpenStack environment all deployed with Juju. So this is interesting because it exposes you to a number of technologies. It exposes you to OpenStack. You learn something about Juju, which it's a pretty slick, pretty neat deployment facility for OpenStack, and you learn a few other things along the way as well. By the way, we will have another version of this course in the pipeline. If you if you prefer Ansible over Juju, we have another version of this where the labs are Ansible based, and that's currently in internal testing, and will come out soon. For the Cloudify bits, for the Cloudify Academy bits here, this course is actually self-register capable. There's currently 30 seats that are open for this course run. So if you want to learn about Cloudify, you can do that as well. And by all means, feel free and welcome to do that. So that is at https://lms.getcloudify.org, and you can start learning on that immediately. What is that? Which email address did you put in? You're in. Okay. Yeah. By all means, feel free and get started on that. Yes. Have you registered on our website? Okay. Can you go to store.hastexo.com, please, and register there? Right? And once you've done that, then I can send you an invite. So what's your what's the email address? Okay, yeah, cool. Got that. Yeah, I got that one. They're completely separate environments. Amir Hazom? Okay. Who's the Mirantis person in the room? Do you want an invite as well, Ilya? There you go. You got it. All right. For those of you who are not here with a laptop, just be informed the slide portion of my talk is basically concluded, right? So what I'm going to be doing now is I'm going to assist people as they go through the course, right? So just so you know that, just so you know, you're not late for lunch. And this is also where sort of my free-for-all period starts. So if you have questions about how this is done, how this is built, and so forth, I'll be more than happy to do that, to answer those. Waiting for it to spin up. Okay. Sure. Okay. His question was, how do we interact with students if they have questions on the material? Excellent question. And this is something that you obviously expect out of a learning management system, right? Here is so in the LMS interface, you have two modes. Where students can interact, or learners can interact with each other, and learners can interact with the instructors. One is a discussion board. It's basically a forum that you can post questions on. You basically have a threaded conversation. It becomes searchable, and so on. And the other is a wiki, where you can post things like, for example, errata that you want to post during a specific course run, right? So OpenEdX has this concept of courses and runs. So a run is basically a course that is offered for a specific time frame. We use monthly runs. So if you book courses on our site, it's always a run for a month, and the learner also has access to the environment for a month. But that's by no means a requirement. You could have week-long runs, or you could have 6-month-long runs, whichever. So, and if we need to communicate some, sort of technical glitch or some sort of issue, just to give you an example, it could be that, I don't know, cloudimages.ubuntu.com is down for some time, right? Or it could be that there was some recent and slightly disruptive change to, say, a Juju charm or something like that, right? This is something that we usually put in the wiki, and then for the next course, it goes right back into the course material, into the labs, and so forth. But you have those two things. You've got a discussion board, and you've got a wiki that you can both use for two-way communications. And then, of course, in addition to that, you've got email and so forth. But the discussion board is really the... I didn't catch the first part of the question. How often? Right. So you're asking how often learners typically put in feedback, or no, or how often they're able? Well, they're certainly able to view this feedback at any time, and it's just a matter of sort of how you organize your team, that you have like someone on standby or someone sort of permanently watching the stuff and so forth. Right. Yeah. Mm. Mm. Right, right, yes, and I mean you can use notifications and so forth like that. Generally, what we believe is that if you need frequent interaction with an instructor, then for a self-paced course, you've kind of failed. The very idea of a self-paced course is that people are, by and large, able to complete it start to finish. Without outside interaction. And if you do get feedback where people run into a problem and so forth, then what that really is it's an impetus for you to change and update and improve the material accordingly, right? Because otherwise, if we had built this such that you do rely on some sort of session with the instructor, which of course you can do like through Google Hangouts or Jitsi or WebEx and so on. The idea of it being self-paced kind of goes out the window. If you only have like office hours that are at certain times and that are locked to a certain time zone, then that quickly becomes problematic. I know that Mirantis, for example, does virtual instructor-driven training, right? But you always lock it to a specific time zone, right? You say, this is an instructor-driven training for Americas, or this is an instructor-driven training for Australia, or this is an instructor-driven training for Europe, and we try to not do that. It's our firm belief that when you talk about the actual fundamentals, whether that's OpenStack, whether that's Ceph, whether that's something else, when you talk about the actual fundamentals, it should be completely self-paced, and it should allow people to operate exactly at their own pace. Speaking of pacing, by the way, maybe that's interesting to the larger group as well. So the content that's in here in our HX 201 course, which is our Cloud Fundamentals course, we used to teach this content in face-to-face instructor-driven training in 2 days. Very, very compressed, and it was pretty packed 2 days, but it was 2 days. Now, of course, we rewrote the whole thing pretty much from scratch when we readapted it for self-paced training. And our assumption now is that if someone spends an hour on this per day, they complete it within a couple of weeks. That's generally our thinking here. So OpenStack Fundamentals basically completed in a couple of weeks if you go at it an hour per day. If you want to do it in like 1 week, or if you want to sort of cram it all the way from start to finish, and you want to complete it in a couple of days, then you can do that as well. You got a question?
And for how much time we gain access for today only, or for a couple of weeks?
So
if I want to complete this course completely, I can for free or no?
Well, we're going to keep this available until the end of the week, right? So if you're, well, okay, sorry, that is Sunday, so that's the beginning of next week for you. Right? Yes? So if you're really fast, you can run through it now. Yeah, that's. And what we do for the customers that buy this on our site is we're saying, okay, you can comfortably finish this in a couple weeks, and we're giving you access to the environment for a month.
How long will it take?
So like I said, if you spend an hour on it per day, it's going to be approximately a couple of weeks. So you're going to be spending somewhere between 10 and 15 hours on the course total.
And also the Cloudify course is available?
The Cloudify course is a bit shorter. So this one is the Openstack Fundamentals one has a total of, I'll have to count, I think it's either 15 or 16 lessons right now. And in the Cloudify one, there's 4. So basically, you learn about the basics of Tosca and Cloudify. You learn to deploy Cloudify blueprint on a single node. You learn to deploy Cloudify Manager, and you learn to use Cloudify Manager to then deploy a multi-node application. Those are the 4 steps. That's not to use the Gigaspaces guy here, but yes, that is available for free, at least for the time being and for the foreseeable future. It's limited to 30 seats per run right now. Okay, so 30 parallel learners per run, and it's first come, first served. One more, Ilya.
Openstack basis. I just want to explain why I'm asking about the interactions as, from my perspective, as a perspective of a community guy. Yeah. The OpenStack is at least 50% is about communication, the OpenStack process.
Right, yes.
And here is only the technical aspect without the OpenStack native interaction tools.
What do you mean the OpenStack native interaction tools?
What it means is that the human interaction, right?
Yeah.
So the networking between people that is lacking out of any online kind of media. I think we have less of that experience, but I think that if you look at the challenge that people are facing, most of them don't have the luxury, and the choice would be not to go to that training, and not to go to a training. So if you could go to a physical training and you could spend the time and do it in the traditional fashion.
See, I think before the session, I had a conversation with a person from IBM, and she shares the common problem that there are some blueprints in the project which are ignored by the community.
Yes.
So the thing is, the challenge is to promote the blueprint to move forward.
Hang on a second. So if we're talking about blueprints, and if we're talking about sort of where the community moves, we are far removed from the basics. We're far removed from the fundamentals. That's why I didn't say all training should be self-paced. I said the fundamentals should be self-paced. You should be in a position to very quickly gain the technical knowledge that you need in order to be able to participate in discussions.
That's very basics. That's the first step. That's the introduction of the OpenStack to the.
It gets you to the point of being able to deploy and run an OpenStack compute environment. That's what it does. Just like our Ceph course gets you to the point of deploying and running a Ceph cluster. No, the Ceph course does not magically make you a Ceph developer. It doesn't get you on the Ceph mailing list. It doesn't drop you into the Ceph Developer Monthly or anything like that. No, it's meant for people to be able to sort of gain the technical knowledge as quickly as they can, so they can learn to participate in these discussions. And I totally agree with you that number one, the human interaction is very important in any kind of open source community. For that matter, really in any community worth its salt, otherwise it's not a community. But this is something, and I agree, this is something that is best provided or best educated about face to face. It's out of scope for the fundamentals, self-paced classes that we're doing here.
The idea that my question was that probably you make some simulation of community-based interaction.
Why would anyone come up with the idea of a simulation of community-based interaction? Like, why would you simulate?
For the same reason, to show the mechanics of contribution.
Yeah, but why would you want to simulate that? Quite frankly, I think that's a silly idea. If you were to actually foster that, if you actually got people to actually communicate with people, that's fine. But I really don't see the value in a simulation of that. Okay. All right. So with that, I think we're gonna wrap up this tutorial. For those of you who are still working on some of the pieces, I'll be more than happy to assist you in the hallway, and you will see me again later this afternoon in an Ignite talk about fragile development, why Scrum is terrible, and what we should be doing instead. So thanks for coming, and I'll see you later.